Okay, so take another look at a new beam with distributed load which is triangular. So now we have to find the shear force and bending moment. So as usual, uh, because I want you to memorize this, I'm going to say this again, which is that the oops, the slope of the shear force diagram equal to distributed load upwards positive, slope of BMD equal to Sfd, jump in Sfd equal to concentrated load upwards positive, jump in BMD equal to concentrated moment counterclockwise negative, clockwise positive. Okay, so those are our rules. So for this one, again, first thing we do is draw the axis x, y. The second thing we are going to do is find reaction forces. And draw full free body diagram with all forces. That looks as usual. I'm going to draw a fairly large one so that we can use it later. So like that, and I have 9 kilonewton, 9 kilonewton. The middle of that is somewhere there, and it goes like that, and then it goes like that. This is 6 kilonewton per meter, and this slope is 2:1. This slope is 2:1. This is 6 kilonewton per meter, and all these things we have to compute. Area equal to 9 kilonewton. Area equal to 9 kilonewton. Notice that the slope here is 0. So now we draw the shear force diagram. So I'm going to draw a line here. And I'm going to start up and I'm going to say, okay, the first thing is very easy. I'm going to jump up by 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the jump. I'm going to notice that the area is 9, so I subtract out 9. So by the time I come here, this height, initial height of 9 minus that gives me 0. So it's got to start here at 9, end up here at 0. And what kind of a shape is it? Do you think it's a straight line? What do you think it is? First, I wanted to realize it's a parabola because the slope of this must be that. The slope of the shear force diagram must be the bending moment diagram. So initial slope is 6 kilonewtons per meter, and it is downwards. Can you see that? Because these arrows are downwards, so it is 6 like that. So remember, the slope of this is the value, not the slope of that. You see what I mean? That's 6. The final slope is 0. So it has to look like that. Okay, there's your parabola. Now notice here, again, it will be negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it has to jump up by 9. So it has to land up there and jump up by 9. This is that. And then the slope here is, so let me mark this down. So this number is that number. And then, so I'm going to mark this down. The slope here also has to be 6. That's this number, right? And it has to be like a mirror image. It has to look like this. It has to start with 0 and land up like that. So how much is the area here? So you're thinking, oh my God, area of a parabola. I don't know how to do it. It's actually very, very easy. What's the area of a triangle? It's half base times height, right? The area of a parabola is 1/3 base times height. The area of a cubic curve is 1/4 base times height. It's actually very, very easy, provided that one end goes to flat like this, 0 slope. So one of the ends of this parabola should go to 0 slope. Otherwise, the formula doesn't work. Area is 1/3, 9 times base is how much? Base is 3. So this distance is 3 units, 3 units. So 1/3, 9 times 3, this is 9. So we know this area. So this area will be minus 9. So remember, negative areas below, positive areas up. Okay, now we are ready to draw the bending moment diagram. So as usual, I'm going to give myself, you can never have enough space for bending moment. So I'm going to give myself, that's not a lot of space, but that's all I can afford. So there it is. So now, what kind of curve will be the bending moment? Remember, the BMD slope is that. So if you look, the initial slope of this is the initial height of this. So initial slope is, it starts out at 0, initial slope is 9. That's this number. What's the slope here? It's 0. How high does it go? It goes to 9 units, so it's somewhere here, and the slope is 0, and then it comes down by 9 units. I don't know whether you can see, but it looks like a cubic curve that looks like this. This height is 9, which is this area. Okay, and the slope is 0, which is this value. So slope of SFD of BMD equals value in SFD curve height in BMD equals change in height, change in height equals area in SFD. So remember that, okay? The slope of the BMD equal to value. So the slope here is equal to the value of the SFD curve, which is 9. The slope here equals value, which is 0. The slope here equal to value, which is minus 9. The height here equals the change in height from here to here. The change in height equals area, which is 9. The change in height equals area, which is minus 9. Okay, and that's it. So this is a cubic curve. This is a quadratic curve. This is linear. So you can see that every time I go, the curve jumps up by 1. Got it? Okay, so we are done.